Hi guys, so I am back with another video on Fmge equation. So PTT is prolonged in which of the following? Hemophilia A, Christmas disease, 1 Willebrand disease, ITP, ABC, BD, or none of the above. So pause and try to answer this question because this question is slightly difficult as compared to previous one which I have discussed. What is PTT? PTT stands for partial thromboplastin time. It is a test that measures the time required for the blood to clot. PTT test is used to assess the functionality of the intrinsic pathway of the coagulation cascade. It involves factors 8, 9, 11, and 12. The PTT test is performed by using the substance called the thromboplastin. Now, what is this thromboplastin? So, thromoplastin it is a substance which plays a crucial role in the coagulation cascade, especially the intrinsic pathway. Now, there are two types of thromoplastin. First is the tissue thromoplastin, also known as the extrinsic thromoplastin, and second is the intrinsic thromoplastin, which we also call as a plasma thermoplastin. So tissue thermoplastin is made by the damaged or injured tissues. Okay, tissue th tissue thermoplastin is made by the damaged or injured tissues, and this and and it is also so, sometimes called as a factor 3. Okay, thermoplastin is also called as a factor 3. Remember this thing. Okay, and it acts as a catalyst in the activation of clotting cascade. Okay, so we can say that the tissue thermoplastin is primarily responsible for initiating the extrinsic pathway of coagulation. Okay, tissue thermoplastin it is useful in the in the extrinsic pathway of the coagulation. Okay, now coming to the plasma thermoplastin. So now plasma thermoplastin it is found in the blood plasma. Okay, and it is involved in the activation of intrinsic pathway of the coagulation. Okay, and intrinsic pathway it is like starts with the Hasiman factor, that is the factor 12. Okay, when the Hasiman factor it comes in contact with the subendothelial surface. Okay, it, it causes the this reaction. Okay, so here is the summary of the intrinsic and the extrinsic pathway. As you can see, in the intrinsic pathway, it starts with the factor 12. That is also called the Hasiman factor. And in the extrinsic pathway, it starts with the factor 7. Okay. So as you can see, there is this is the tissue factor. Okay. This tissue factor it is also called as the thromboplastin. Okay. And in the intrinsic pathway, as you can see, the factor 12 in the presence of calcium, it converts factor 11 into its active form. Factor 11, it converts factor 9 into its active form. Yeah. Then factor 9, in the presence of factor 8, it converts the factor 10 into 10A. Okay. Then 10A, in the presence of factor 5A, platelet phospholipids, and calcium, it converts prothrombin into thrombin. Okay, and this thrombin then converts the fibrinogen into fibrin monomer. Okay, and factor 13 in, in the presence of in the presence of thrombin, it converts factor 13 into 13A, and this 13A with the fibrin clot, it forms a stabilized fibrin clot. Okay, so this is the review of the coagulation cascade. This is very important. Now, what happens in the hemophilia A? So, PTT, partial thromboplastin time, is increased in hemophilia. Why? Because in this disorder there is a deficiency of the clotting factor 8. Okay, so the intrinsic pathway of the coagulation cascade, which involves factor 8, 9, 11, and 12, are affected, which causes the PDT to be increased. Now, coming towards the Christmas disease, it is also called as the hemophilia B, and in this disorder there is a deficiency of the clotting factor 9, and it also results in the prolonged PTT values. And remember, guys, hemophilia A is more common than the hemophilia B, and is characterized by a deficiency of factor 8 rather than factor 9. It means that the hemophilia A is in the hemophilia A there is a deficiency of the factor 8, and in the hemophilia B there is a deficiency of factor 9. Von Willebrand disease. Now, what is one Willebrand factor? So it is a large multimeric glycoprotein that plays an important role in the blood clotting. It it acts as a carrier protein for clotting factor 8 and promotes the platelet adhesion and aggregation. As you can see, then that here there is a in- involvement of factor 8. So this will also contribute to the increased PTT values. Okay. So now, the origin of the von Willebrand factor. So it comes from the endothelial cells and the platelets. Okay. So and it promotes the platelet adhesion and aggregation. Okay. And it is involved in the abnormalities in other coagulation tests like one Willebrand factor antigen, uh, ristocytin cofactor activity, and factor 8 levels. Immune thrombocytopenic purpura. ITP, immune thrombocytopenic purpura, is a condition in which there is low blood platelets count due to immune system dysfunction. While it can lead to bleeding tendencies, it does not typically affect the intrinsic pathway or prolonged PTT. Okay, this is important. It typically does not affect the intrinsic pathway or prolonged PTT. Platelet-related tests like platelet count and bleeding time are more commonly used to diagnose and monitor the ITP. Okay, guys. So what will be our answer? It will be the factor. This one Willebrand factor, hemophilia A, and the Christmas disease. So our answer will be A, B, C. Thank you, guys. And you need to remember what is this, what is the hemophilia, what is the Christmas disease, what is the one Willebrand factor, what is PTT, and what is ITP. Thank you.